So, welcome to PICO Stories Researchers Night, a podcast where science meets storytelling. I'm Evi Koursoumpa, and in today's episode, we are going behind the scenes of one of Europe's most fascinating scientific facilities, the Virgo interferometer at PICO European Gravitational Observatory in Pisa, Italy. We'll be speaking with Francesco di Renzo, who is the technical characterization coordinator within the Virgo collaboration. We'll explore what happens inside the Virgo, how gravitational waves are detected, and why science communication matters now more than ever. So let's dive in.
So, hello everyone. Thank you for inviting me, Evi. It's a pleasure to be here.
It's a pleasure to have you here, Francesco.
Discussing about science and especially how to engage people in this fascinating world. So, please, go ahead freely. Ask whatever you want to hear about.
So, first, we would like for you to introduce yourself to the audience that might listen to us and describe your role here at PICO.
Okay, so the Virgo detector, as well as the LIGO detectors in the United States and the Kaga detector in Japan, are probably the most sensitive instrument to measure difference in distances, more specifically strains, which is the effect produced by gravitational waves passing through the Earth. So gravitational waves are emitted by astrophysical searches. So we need this super precise instrument to do astrophysics. Our instruments collect a huge amount of data, and my job here is to assess the quality of this data for astrophysical searches, right? This is basically my job in synthesis. More specifically, I look at the data recorded by Virgo, but also by LIGO detectors. We have some metrics, some quantities, summarizing how good is the data, and more specifically, what are features in the data that may affect the results of astrophysical searches. In particular, at the end of the day, what we want to do is to publish the result of our searches, but we also want to be sure that what we publish, what we infer about the universe, it's reliable. We can trust about it. So it is important that the data has no spurious contamination from instrumental noise, environmental noise, and other artifacts that are not of gravitational origin.
It's very, very important, of course, for science in general to have very reliable data. It's mandatory in any case. For the listeners that are not familiar with the concept of gravitational wave interferometer, what exactly is Virgo detecting?
Okay, so human beings, since
it's very, very important, of course, for science in general to have very reliable data. It's mandatory in any case. For the listeners that are not familiar with the concept of gravitational wave interferometer, what exactly is Virgo detecting?
Okay, so human beings, since early ages, are familiar with the light emitted by stars. Mm-hmm. Bright objects emit electromagnetic wave, which we see and we measure by means of telescopes, and this has been, let's call it, traditional astronomy until quite recent years. Gravitational wave interferometers do something similar, but using gravitational waves. It is, I said, bright objects emit light. Massive objects, gravitating objects, emit gravitational waves. And so it's a form of, it's a vector, it's a mean of communication similar to electromagnetic wave, the gravitational waves. And Virgo is basically an antenna for these waves, these gravitational waves. Specifically, how we know that a gravitational wave is passing through the detector, is interacting with the detector. Well, as I mentioned, the effect of gravitational wave is a strain, that is a relative variation of the distances between reference masses. These masses are our mirrors, and we use laser light as a ruler. With the laser light in a specific optical configuration through between these mirrors, as an optical path that makes the detector specifically sensitive to this difference in distance, this strain. And what you measure is the interference of light, is the signature that something changed the relative distance between the test masses, between the mirrors. So from that signal, we infer the strain, the intensity of the gravitational wave that passes through the detectors. And from the properties of that signal, we infer then the properties of the source, the astrophysical source that produces it, like binary black hole system, neutron star system, etc. Everything that possesses gravity and interact in a somewhat catastrophic way, let's say.
How a typical day in the observatory looks like?
Okay, so fun fact, there is no actual distinction between day and night, because as you can imagine, stars decide to coalesce and to merge and emit gravitational waves when they want.
Yeah.
So basically, I typically receive notification of a signal in the middle of the night, and the fun fact, night is when our detectors are more sensitive, because basically there are less disturbances from anthropogenic origin, environmental origin. You know, everybody's sleeping, but the universe. So typically, okay.
The universe calls.
The universe calls. Literally, I have notification activated on my phone from gravitational wave database, GraceDB, which whenever there is an alert for something that could be a gravitational wave signal, you receive notification. You typically go online, check. There are procedures that I'm coordinating about doing a prescribed list of checks about the quality of the data, again, that no software issues occurred in the pipelines, the algorithm that analyze the data, and everything is okay. We trust on that, on the goodness of that alert, or to put it in another way, we have no reason to retract the alert. So we trust that, and we send a message in a specific format, a NASA GCN, to the whole astrophysical community. So everybody, within a few tenths of minutes, know that we received that signal. And this is important because we basically tell all the astronomical partner to point their telescope toward that region in the sky. It's important often to do that quite quickly, because there can be a flash of light that has been emitted in conjunction with the gravitational wave signal. So it's important to have multiple messengers that witness the same astronomical phenomena. Okay, the coalescence is described by the gravitational wave signal, but also by the electromagnetic signal, and possibly also neutrinos and basically neutrinos, not many other particles. So we work 24/7 in many sense.
Moving from the science aspect and research part of gravitational waves to how we communicate them, or why is it important to communicate them. So we know that every year at the last Friday of September is Researchers' Night. And now PICO is also one of the main main organization parts of the Researchers' Night in different parts of Europe, and one of those collaborators that are working with that is also EGO. Why is Researchers' Night important for gravitational observatory like EGO?
Well, in general, this kind of communication events, science communication events, are very important to tell people, general public, but also other scientists involved in other kind of research, what we are doing, sharing ideas, even with people not scientists, can be first of all informative to tell them what we do with public fundings, and also to receive their feedback. In the years, I have started many very fruitful relationships with just common people interested in our research, and every now and then sending me suggestion about, oh, did you try this analysis to investigate that problem, or oh, it's awesome how many detections you did in the last month. There have been improvement to the detectors, or the opposite. I've received no messages in the night about potential alerts for gravitational waves. Did something happen to the detectors, or we have created an important community of citizen scientists around this project. But even if there is not a return, they are not really interacting with us, it is important that we tell them what we are doing to inspire them, especially inspire young new generations, young students, or even university students about what we do. And it's I think it is somewhat a duty of us, the scientists, towards the whole society.
What kind of visitors do you usually have during the researchers' night? You said nowadays could be scientists, could be general public. Is it focused on some specific age?
So it varies depending on the time of the day. So usually our stands, our events open in the afternoon, and first of all we meet families with children, with probably grandparents bringing their young nephews to these events. So moving forward, we meet, for example, university students when they finish studying. So before dinner time, like 7 p.m., they start populating our exhibition. So we meet really a very diverse kind of audience. So it's very interesting also to see how questions evolve. For example, at some point you meet your students who were teaching to them a few hours before, then they come asking you the question about what you do. So it's an interesting experience, and it's also useful because roles are often flipped, in the sense that the students become the one asking you to explain some topics, really eager to learn what you do and why. So I will say, very diverse public.
So
students from every grade, from every school, and people of all ages, literally.
So when you preparing activities for researchers' night, you have to focus on a diverse public, from people that know, from people that are new to this, that introduct, up to kids that they don't have formed the concept of physics or stuff like that. How do you reach that goal to communicate properly? How do you conceptualize the activities that you want to do? Is it like also from some experience with previous interactions, some ideas that come in handed, or how is it formed?
So to be honest, watching a lot of YouTube videos, because there are these exercises of explain potentially difficult concepts at 5 different levels to people preschool age, to elementary school students, up to experts in the field. So I often try this exercise. Of course, I decide the subject first, usually subject connected to what I do, but sometimes also a subject that I would like to present to the public. For example, this autumn I will do some lectures about stellar evolution, which is not exactly my subject, but this is really connected because I often talk about black holes, neutron stars, but people typically don't know what they are. So I thought it was useful for me and for my colleagues to have people with a sort of exposition to these concepts. So right now I'm trying to figure out how to describe them to this different kind of public, up to expert in the subject, still considering that I'm not an expert. So I try to focus more on what I know best in order, not to
because it's very important when we communicate science to do it precisely, so we don't...
Exactly, not misleading.
Exactly, not misleading, because we see also in other concepts like movies and books and stuff that some parts of science might be not properly presented in a way that could create some confusion in the mind. That's why there's a separation of the science fiction part. But for researchers, when they're communicating their work, it's very important to do so that it is precise, but at the same time it will help the people that are listening to imagine it in an entertaining way, or the best way possible. So it is a challenging factor to simplify the information but keep it also precise. Have you noticed an impact from past events to the society in Italy or in Pisa? Or because I guess the events are not only localized in Pisa. I guess visitors who would come in PICO, but also IGO would visit maybe other facilities.
Yes, more or less. Many things that you mentioned, I witnessed in the years. I've been participating to European Researchers' Night since 2016, so it is almost it's 9 years that I'm doing that. So I've met many people here at IGO as visitors, many people that I've met them just quickly at European Researchers' Night, downtown Pisa. They came for a visit and said, "Oh, I just had a few minutes to pass by your stand. I was interested, but I didn't have time to know more about this thing, so I booked this visit, and here I am." More specifically, I said 9 years. So I was mentioning before that I often met high school students in general, visiting just out of curiosity the exhibition, this initiative. And now I can tell that I'm collaborating with them, which they've become university students, they've finished their master's thesis, and now they are members of the Virgo collaboration, inspired by the exhibition that we did like 5, 7, 9 years ago at European Researchers' Night. So it's fun, and now I'm trying to convince them to come to the other side, being them the speakers at some of these events. It is fun. They used to be on the other side, just the general public, a few years ago, and now they tell what I used to tell them a few years ago. So this is a very nice reward for me.
So inspiring the young people is a very important aspect of the Researchers' Night, and be open to them about what we do and see them follow these footsteps and becoming them the next physicists and scientists. But during the Researchers' Night, or in general during science communication activities, what do you think is the biggest challenges when trying to communicate advanced, especially research, to the public?
Well, try to find a common language, in the sense that just briefly looking at the person, the people who's talking to you, try to guess more or less what does they know, what do they know, what's their background, in order to speak this common language, and also more or less guess what they would like to know. because often it's not the question they ask, is the answer they look for. It can be a little bit tricky. Often it happens that physics students come to me with some apparently trivial question, and then they start with high-level math. But isn't it the rotor of something? Come on. This is just because they are trying to prank me. But find this language is important. It's important in all aspect of communication, not just science. Here is specifically important because you have a limited amount of time to communicate your science, but also to engage. So you should be technical enough for the people who's talking to you to be attracted by what you do. So not oversimplify, not overcomplicate.
Very important.
Yeah.
So have you had any memorable or unexpected interaction during public event?
Definitely. And probably I must say that with kids, they are brilliant, and they ask some questions that make you wonder whether you really understood the thing in the first place. For example, I had this kid where I was showing to the group some very trivial things like this mass on this elastic fabric which bends space-time. You put another mass and you describe circular orbits. And this kid said, "Why circular? Why not squares?" I was like, "Yeah, how can I explain this simple concept in a few words?" I was not prepared to answer that question. Also, I needed myself to realize why not square. Good question.
Yes.
I mean, you cannot simply say good question. Let it be. You have to imagine some interesting question, understandable by the kid, also, which is satisfactory by the people. So often kids are great at this kind of episode. For this kind of episode. So definitely.
And kids' imagination is also very open.
Ingenuity, they are.
So you can easily think, why not that? But you don't question yourself enough in some kind of simple concepts. So in the end, why do you think it's important for scientists to be involved in communication and education efforts?
Because it's too nice, too awesome what we have the fortune, we have the privilege of doing. But it will be a shame to keep it all for ourselves. It is important that we describe, that we tell, that we inform people about what's our job, what's our funds, and to be themselves inspired by what we do. And additionally, because there is this awesome exchange of opinions on the same level, the sense that we are not the professors teaching.
Yes.
There is an open communication of ideas, an open exchange of ideas. So it's as I said before, a sort of duty that we do for the society, but also it's rewarding. It's we gain a lot in knowledge, receiving also the expertise, the opinion, the comments, the review by people, by common people.
This kind of activities and science communication is putting scientists and the public to like a common table. Let them discuss, let them exchange, let them share, and that's the magic of it all in the end. To be able to have an open discussion and see what can be learned in both sides. That's very nice. So if you could send a message to young people that they might want to attend the research night or other events for science communication, what would it be?
Well, don't think that you're not prepared enough, that people, the scientists that you're going to meet, the researchers that you're going to meet, will talk about a too difficult language. I promise they will try the best to speak a common language that you will learn from what they say. But additionally, come with questions. Whatever questions you had on that topic, on general topic of research, please don't hesitate to ask them. And also, it will be fruitful if you come out after these events with a lot of questions still that you will pursue in your personal research, or that you will ask at the next event. So you have also a reason to participate, to keep on participating to these kind of events. So questions are what direct our research, what lead us to what we are doing. So questions are more important than answers in many ways. So don't underestimate that.
Okay. So thank you, Francesco, for being here and sharing all this information with us about Research Night and science communication, and of course Virgo, gravitational wave detector here in Pisa.
Thank you for organizing this podcast, being part of these events. I guess we all agreed on the importance of this kind of activity for the society, for science itself. So thank you too.
So thank you also for watching and joining us to this journey through science and storytelling. Until next time, keep asking questions, stay curious, and never stop exploring. Ciao!
Bye!
Great!
We did it!
Yeah!
Thank you!
Okay, it's recording. Great!
Yeah.
We can talk.
Check, 1, 2, 3, 1, 2, 3.
Welcome to PICO Stories, Researchers Night!